Hello and welcome to today's class. Today we are learning salts. Please, if you have not watched the previous videos, kindly check out the previous videos and watch them in order to enhance your comprehension. So let's dive into our class. Now, what is a salt? A salt is a substance or any substance formed when all or parts of the ionizable hydrogen ions are partially or completely replaced by metallic or ammonium ion. This is the right definition of a salt. When some or all of the hydrogen ion have been partially or completely replaced. Now we have different types of salts, and they include, number one, we have what we call the normal salts. We have what we call the acid salts. We have what we call the basic salt. We have what we call the double salt. And the last but not the least, the complex salt. So let's explain these different salts. Okay, so let's look at normal salt. Normal salt is a salt formed when all the replaceable hydrogen ions have been completely replaced by metallic ion. All the replaceable hydrogen ions have been completely replaced, not partially, completely replaced by metallic ion. Example, if you have hydrogen chloride reacting with sodium hydroxide, you will discover that you have sodium chloride plus water. So in this reaction, you will find out that there is no hydrogen at all here. So this tells you that this salt, this is a salt and this is water. This tells you that these salts have been completely replaced. There is no hydrogen present. So we refer to it as what? Normal salt. Hence, all normal salts are neutral to litmus paper. They are neutral to litmus paper because all the hydrogen that would have formed an acid, all those hydrogen that would have formed an acid have been removed. They have been replaced completely. So they are neutral to litmus paper. Let's look at acid salts. Okay, so let's look at acid salt. Acid salt is formed when the replaceable hydrogen ion have been partially replaced by metallic ion. So let's look at it. For example, let's say you have tetraoxo sulfate 6 acid plus potassium hydroxide. That will give us potassium hydrogen tetraoxo sulfate 6 plus water. So what do you observe in the salt? Here in the salt, you discover that there is a hydrogen ion. In the salt, there is a hydrogen ion. That means that these salts have not been completely replaced by metallic ion. It has been partially replaced. That is why you still have some element of hydrogen remaining. So any salt that has hydrogen present has not been completely replaced. For example, other examples are, if you have sodium hydrogen tetraoxo sulfate 6, this is a what? Is an acidic salt. Any salt that has presence of hydrogen here is an acidic salt. Hence, it has been partially replaced. Okay, so let's look at basic salts. Basic salts are those salts with hydroxide ion. Basic salts, they contain what we call hydroxide ion. Why? Because they have insufficient supply of acids for complete neutralization of the base. They have insufficient supply of acid to completely neutralize them. So all basic salts contains hydroxide ion. Examples, you have magnesium hydroxide triazonitrate 5. Notice that they contain what? Hydroxide group. So these are what we refer to as basic salts because they don't have sufficient supply of acid. Let's go to the next type of salt, the double salts. So we look at double salts. What are double salts? Double salts are those salts that ionize to produce three different types of ions in solutions. They produce three different types of ions in solutions. Now, usually, the formula is this. Usually, the formula is this. Now, the three different ions in solution they produce are 2 are positively charged and 1 is negatively charged. These are the three different ions they produce. So, for every double salt, the first element must be a univalent. Univalent means one valency. Then the second one must be a trivalent. Trivalent means what? 3 valency. Then the anion or the negatively charged you are going to have, the third ion will be an anion, a negatively charged ion. These are the three things you must note when you are writing a double salt. Okay, for a double salt, the first element must be univalent, the second element must be trivalent, and the third element must be an anion, a negatively charged ion. So let's look at how to write it. For example, this is potassium univalent. We are looking at trivalent aluminium, then tetraoxosulfate 6, and maybe 7 molecules of water. Are we together? Let's look at another one. You may have potassium, a trivalent, chromium. Chromium is trivalent. Then tetraoxosulfate 6, say 10 molecules of water. So it is wrong to write it this way: magnesium or potassium, magnesium. Why? Because potassium is 1, but magnesium is 2. So you must be careful to ensure that the valency of the elements you are writing rhymes with this formula. This is how double salts are formed. Now, this one here is what we refer to as alum. Double salts, many of them, they form alum. Many of the double salts, they form alum. This is an example of a double salt, alum. Alum is an example of a double salt. So these are examples. These two are examples of double salts. The first must be univalent, the second must be trivalent, the third must be an anion, then with its solution. Okay, so let's look at the last type of salts, complex salts. These are salts that are formed by mixing two simple salts together. However, one funny thing about these salts is that when you mix them, they now form that two simple salts, but at the end of the day, they form a complex ion. That is why we call them complex salts, because they form complex ion. For example, you mix copper 2 tetraoxosulfate 6 and ammonium hydroxide solution, you will come up with what we call tetramine copper 2 ion. Look at it here. You will come up with this. Is a complex salt. Now, most of those complex salts, they are ion. They are ionized. Most of them are ionized. So this salt is tetramine copper 2 ion. This is an example of a complex salt. Another example of a complex salt is what we call potassium hexacyanoferrate 6. Remember what I told us, they are usually ionized. They are usually ionized. So this is potassium hexacyanoferrate 6 ion. Another example is silver. This is tetramine silver 1 ion. Tetramine silver 1 ion. Remember, all of them, whichever one it is, they must be in ion. So these are what we refer to as what? Complex salts. All right. Okay, so let's look at the uses of salts. Number one is ammonium chloride. Ammonium chloride is used as making of washing soda and electrolytes, especially in dry cells. You use ammonium chloride as a paste in dry cells for electrolytes. Calcium triazocarbonate 4 is used in neutralizing acidity in the stomach. Calcium chloride is used as an antifreeze, something that defreezes snow and any other cool thing. Then calcium tetraoxosulfate 6 is used in making POP, plaster of Paris. Magnesium tetraoxosulfate 6 is used as a laxative. In fact, anything containing magnesium is used as a laxative, something that helps to evacuate your bowels. Then potassium triazonitrate 5, anything triazonitrate 5 is used in making explosives. Explosives could be matches, gunpowder, anything explosive, as well as fertilizers. Then sodium chloride is used in preservation. This one is very popular with us. When you don't want your meat to get spoiled easily, you're going to spray or apply some salts on it. That table salt we use is what we refer to as sodium chloride. It's also used in glazing pottery. So let's look at solubility of salts. Okay, so let's look at solubility of salts. This is a very popular question in JAMB. All right, so for salts, any salt that contains potassium, sodium, or ammonium, all salts that contains potassium, sodium, ammonia, they are soluble. All salts that contains trioxonitrate 5 are soluble. All triazonitrate 5 salts are soluble. Now, for chloride, all chloride are soluble with the exception of 2 salts, lead and silver. So that means that lead 2 chloride and silver 1 chloride are insoluble, although this one is soluble in hot water. It's soluble in hot water. So all chloride are soluble except lead and silver. Then all tetraoxosulfate 6 salts are soluble except lead, barium, and calcium, although this last one is slightly soluble. These 3 salts, they are tetraoxosulfate 6. So if you have lead 2 tetraoxosulfate 6 is insoluble in water. Barium tetraoxosulfate 6 insoluble. Calcium tetraoxosulfate 6 is insoluble. Then all triazocarbonate 4 of sodium, potassium, and ammonia are soluble. The only soluble salts of triazocarbonate 4 are these: sodium, potassium, and ammonia. Every other salts are insoluble. Every other salt that contain triazocarbonate 4, like calcium triazocarbonate 4, magnesium triazocarbonate 4, all these other salts that contain triazocarbonate 4, with the exception of these ones, are insoluble. Please take note of this because JAMB has a way of asking questions on this topic. They can give you something like, which of the following salts is soluble? They will not say A, calcium. Which of the following salts is soluble? A, calcium triazocarbonate 4, B, magnesium triazocarbonate 4, C, lead tetraoxosulfate 6, and then D, they may now write ammonium tetraoxosulfate 6. Ammonium tetraoxosulfate 6. What will be your answer? If you were in the JAMB hall and you saw this question, what will be your answer? The answer to this question, this is triazocarbonate 4. Only triazocarbonate 4 of potassium, sodium, and ammonia are soluble. Therefore, this one is insoluble, this is insoluble. Tetraoxosulfate 6, all tetraoxosulfate 6 are soluble with the exception of lead, beryllium, and calcium. But tetraoxosulfate 6, ammonium of tetraoxosulfate 6 is soluble. So the only soluble salt here is this. So please memorize this. Memorize them. Memorize the soluble ones and memorize the exceptions. Is that okay? All right. We have come to the end of our class today. Thank you very much for watching. Please do well to subscribe to our channel and invite your friends to do the same. Thank you for watching. Please subscribe to our channel so that you get notification when a new video is released. The next topic for the next class will be on the liquescence, efflorescence, and the rest. Please go down to the video now and watch. Bye.